Hi guys, today we're going to be working through lesson 33A in our Ready Math textbook. So if you do not have your Ready Math textbook out, now would be a good time to get that out. I'm actually currently on page 374. So feel free to work along with me, write in the answers. If I'm going a little bit too fast, you can always pause the video or rewind the video and so on. So let's go ahead and get started. You have learned about equal parts of shapes and finding area. In this lesson, you will learn how to form and break apart rectangles into squares of equal area. Students at Memorial School painted square tiles. There's the square tiles there. See how they're different colors? The tiles were put together to make designs on the office walls. Each design is a rectangle made from 12 tiles. So they're going to take all these colored tiles and put them together to make one big rectangle. What are some different rectangles that can be made using the 12 tiles? Let's look at the questions that they ask us. So we have A, B, and C on this page. A says, what if you put the tiles in rows that each have 3 tiles? How many rows would you make with 12 tiles? Draw squares in this rectangle to show what this looks like. So the first question says, what if you put the tiles in rows that each have 3 tiles? So I'm going to make a row of 3. So as you can see, there's one row. If I make 2 vertical cuts, I have 1, 2, 3. So the first row has 3. Our goal is to use 12 though. So I've only used 1, 2, 3. So I'm going to have to keep adding rows. So there's row 2 with 3. So 1, 2, 3, 4, 5, 6. And then I'm going to add 2 more rows. I'm going to make a couple cuts here. So right now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's the 12 tiles kind of pushed together to make this one bigger rectangle. So it says, how many rows could you make with 12 tiles? Well, if we had 3 in each row, we would have 1 row, 2 rows, 3 rows, and 4 rows. So the answer to this question would be 4 because there are 4 rows and 3 in each row. All right, B, imagine you turn the rectangle on its side. Now how many rows does the rectangle have? How many tiles are in each row? Draw squares in this rectangle to show what this looks like. So they're actually wanting this rectangle to be tipped over and turned on its side. So these are the same, except I'm going to make my cuts a little bit different. The first rectangle, we have 4 rows with 3 in each row. Well, this one's going to be a little bit different. This one, we're going to have 3 rows. So if I make 2 cuts, I have 3 rows, and I'm going to need 4 in each row. So I'm going to make 3 cuts this way. 1, 2, 3. Okay, so let's count. We should have 12 in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So these are the exact same, except it's just tipped over. So the question says, how many rows does the rectangle have? Well, it has, let me change the color here. It has 1, 2, 3 rows. So the answer for this one is 3. How many tiles are in each row? 1, 2, 3, 4. There are 4 in each row. So the answer for that one is 4. Okay. C, there are other ways you can make rectangles with 12 squares. Explain how you would find the other ways. On a separate piece of paper, make drawings to show what the rectangles look like. So today we're not going to do any of the drawing on the extra pieces of paper, but we should be able to explain how we would arrange these square tiles to make 12. So our goal is to make a new design using the 12 tiles provided at the top, okay? But we need to think with with rows and columns in our head, okay? We got to think rows and columns. Remember, rows go left and right, and columns go up and down. So how can we get 12 squares to fit in a rectangle, but we cannot use 4 and 3? Well, there's a couple different ways we can do this. If we had these tiles laid out in front of us, we could move them around and try to guess and check different arrangements to see if it would work. But unfortunately, we don't have those in front of us to be able to manipulate, to move around. So another way we could do it is we could actually use multiplication facts. So in your head, think what two numbers multiplied together are going to give you 12. So blank times blank equals 12. And we cannot use the factors 4 and 3. So if you think, what two numbers can we multiply to get the product or the answer of 12? Well, the first way we could do it is 2 times 6. If I had a rectangle with 2 rows and 6 in each row, I would be able to fit 12 boxes in that rectangle. And if I flip those factors, I could say 6 times 2, which would be 6 rows and 2 squares in each row. Remember, we can flip those factors, okay? So I can say, I'll write this here, 2 times 6. Sorry, I'm trying to write this with a mouse. It's not the easiest thing. Or we could say 6 times 2. Remember, we can flip those factors. Is there another way we could come up with a rectangle? Well, yes. We could actually say 1 row of 12, or 1 times 12, because 1 times 12 is 12. That would be a long, skinny rectangle. And we can flip those factors as well. We can do 12 times 1. So that would be 12 rows and 1 square tile in each row. So there's many different ways we could arrange this design, okay? Let me go ahead and erase these answers real quick before we move on to the next page. If I don't erase it, it'll actually pull those answers down. So if I pull it like this, you can, oop, here we go. Let's try it. If I pull it down, you see how the answer, yeah, that's why I have to erase it. All right. Okay, let's look at the next page. It says, on the previous page, you formed different rectangles using the same size squares. You can also break apart a rectangle to show parts that are all the same size. Each rectangle below is broken into equal parts. Each part is a fraction of the whole area. So these 4 rectangles, these are 4 whole rectangles. This is a whole rectangle, this is a whole rectangle, this one and that one. Those are whole rectangles as well. The first rectangle is actually divided into 4 equal pieces. 1, 2, 3, 4. All 4 pieces are equal. Okay, so those are fourths. This one is also broken into fourths, 4 equal pieces. 1, 2, 3, 4. So these two are similar because the wholes are divided into fourths. Each piece is worth 1/4. Now these two are different. These two are cut into eighths because they have 8 pieces, 1, 2, 3, 4, 5, 6, 7, 8 pieces that are all the same size piece. So this would be cut into eighths, and this one is cut into eighths as well. These long, skinny rectangles, there's actually 8 of them, and they're all the same. Okay, so these two are fourths, these two are eighths. This should sound familiar because we have learned fractions before. Okay. Right here it says the shaded parts of each rectangle below cover 1/4 of the whole area of the rectangle. The first 2 rectangles show 1 out of 4 equal parts shaded. So let's start with that, the first 2. So one piece in this rectangle is colored in, just one. You see it right there. So 1 is colored in out of 4 total. Now, some students, when I first would start teaching them fractions, a lot of students like to say it's 1/3. How did they get that? They're thinking, well, 1 is colored in and 3 are not colored in. So it must be 1/3 or 1/3. That is not correct. It would be 1/4 because it's 1 out of 4 total pieces. The total, you have to count the colored and the ones that are not colored all together. So this would be 1/4. This one, we have 1 colored in out of 4, is also 1/4. Now up here it says the other two rectangles show 2 out of the 8 equal parts shaded. So this one shows 2 colored in out of 8 altogether. 1, 2, 3, 4, 5, 6, 7, 8. 2 out of 8. So that's 2/8. And this one here, 2 are colored in out of 8. So that's 2/8. So we can kind of group these together. These two are both 1/4, and maybe I'll do a different color. And these two are 2/8. Okay. So it says all shaded areas are equal in size, even though the shapes of the parts and the number of parts are different. If there is more than one part shaded, the shaded parts do not need to be next to each other. Each rectangle at the right also shows 1/4. So they're saying these two also show 1/4. Now, most students might say, well, I see 2 are colored in, 2 out of 8. I would think that the fraction for this would be 2/8. Well, that is true. However, 2/8 and 1/4 are equivalent. If you remember, that word equivalent just means they are equal. Okay, 2/4, or I'm sorry, 2/8 and 1/4 are equivalent. This one also says 2/8, but we can say that it's also 1/4. Okay. This one kind of looks like this one, except the pieces are separated. And they're saying that's okay. They don't have to be colored in right next to each other. Like these are colored in next to each other, these are colored in next to each other. But down here, they are kind of split up. Okay, so there's one question at the end. It says reflect. Number one, if you divide a rectangle into 6 same sized squares, are the areas of the squares equal? What do you know about the area of each square compared to the area of the whole rectangle? And the answer to that question, at least the first part of the question, is yes. The areas of the 6 same size squares are equal. They are equal. Each square is 1/6 of the area of the whole rectangle. So each little piece, one piece, is worth 1 out of 6, or 1/6 of the entire whole.